In a week marked by significant discoveries and stunning visual phenomena, NASA has once again captured the imagination of the public and scientists alike with its latest astronomical findings and captivating images. From the unveiling of the spiral Galaxy NGC 2566 to the mesmerizing display of the northern lights observed from the International Space Station ISS, these events underscore the dynamic nature of space exploration and its ability to ignite wonder and inquiry. On May 26, 2025, NASA's Astronomy Picture of the Day featured a breathtaking infrared image of the spiral Galaxy NGC 2566 located a mere 76 million light-years away from Earth. This image, captured by the James Webb Space Telescope, showcases the galaxy's bright central bar and its prominent spiral arms. What's happening in the center of spiral Galaxy NGC 2566? The accompanying explanation asks. Highlighting that the vibrant rays emanating from its center are not actual features of the galaxy but rather diffraction spikes caused by the telescope structure. The central region of NGC 2566 is suspected to harbor a supermassive black hole, although it appears to be currently inactive, providing astronomers a unique opportunity to study its dynamic gas and dust clouds that are crucial for star formation. Meanwhile, on May 23, astronaut Nichole Ayers aboard the ISS experienced an unexpected visual treat when she witnessed the northern lights while attempting to photograph active weather systems on Earth. The aurora showed up this last weekend when I wasn't expecting it. Ayers shared on social media, revealing her delight at the vibrant display that illuminated the skies over the northern United States and Canada. The appearance of these dazzling lights coincided with a geomagnetic storm predicted to reach KP levels of 6 out of 9, indicative of heightened solar activity. These auroras are produced when charged particles from the Sun collide with Earth's magnetic field, creating a stunning array of colors. As the excitement from these astronomical events unfolds, the scientific community remains vigilant about the future of space research in the United States. Amidst growing concerns, a petition has begun circulating to combat proposed cuts to NASA's science budget, which could jeopardize future missions and discoveries. The National Space Council, while currently under scrutiny, is still perceived as a critical component in the ongoing dialogue surrounding space exploration policy. Advocates for the agency stress the importance of sustained funding for scientific endeavors, emphasizing that the quest for knowledge about our universe is more vital than ever. As we reflect on these remarkable occurrences, it is evident that the exploration of our cosmos continues to yield extraordinary insights and breathtaking visuals. The discoveries made by the Webb telescope and the unexpected beauty of the auroras serve as a reminder of the wonders that lie beyond our planet. Looking ahead, the ongoing advocacy for NASA and the potential for new missions promise to keep the spirit of exploration alive, fostering curiosity and inspiring future generations to reach for the stars. In an exciting convergence of Earth science and space exploration, the 2024 Stratospheric Aerosol and Gas Experiment 3 SAGE 3 meeting held at NASA's Langley Research Center brought together some of the leading minds in atmospheric research. The event, which took place from October 22 to 23, 2024 in a hybrid format, hosted approximately 50 scientists representing various institutions including NASA, the National Oceanic and Atmospheric Administration (NOAA), and universities across the United States and abroad. The SAGE 3/ISS mission, which has been operational since 2017 aboard the International Space Station ISS, plays a critical role in monitoring the Earth's atmosphere, specifically targeting stratospheric aerosols and gases. The meeting was a platform for participants to discuss project updates, data validation efforts, and future mission synergies, particularly in light of potential new missions slated for launch in the early 2030s. Kicking off the sessions, June Wang, the SAGE 3/ISS science team leader from the University of Iowa, and David Flitner, the project scientist from NASA Langley, welcomed participants and set the stage for a rich exchange of ideas. Richard Ekman, an emeritus program scientist from NASA headquarters, delivered opening remarks that highlighted the importance of the SAGE program in understanding atmospheric changes. The first day saw presentations focused on project status, including the successful continuation of SAGE operations through 2026 thanks to NASA's approval of an overguide funding proposal to support community validation initiatives. Flittner characterized 2024 as a year of growth for the SAGE team, emphasizing the significance of ongoing projects that will contribute to the 2026 World Meteorological Organization's International Ozone Assessment. Among the notable achievements shared was the release of version 6.0 of the SAGE 3/ISS data products, which promises to rectify previous biases in aerosol data retrievals, a critical improvement for aerosol research and climate modeling. Aerosol research formed a significant part of the discussions, with presentations addressing the development of the global space-based stratospheric aerosol climatology GLOW-SSAC product and the assessment of various instrumentation, including the ozone mapping and profiler suite. The scientific community is keenly aware of the implications of aerosol data on climate change and air quality, leading to intense scrutiny of the methodologies and data used in analyses. The second day of the meeting shifted focus to advanced modeling techniques and new satellite missions. Presentations covered a range of topics, including the potential impacts of increased launches into low Earth orbit on atmospheric composition and the upcoming Canadian contribution to NASA's Earth System Observatory. Stephen Pawson from NASA's Goddard Space Flight Center discussed advancements in modeling the upper troposphere and lower stratosphere dynamics, stressing the impact of accurate water vapor representation in climate models. As the meeting concluded, there was a palpable sense of urgency among attendees regarding the future of atmospheric monitoring. The retirement of key satellite instruments such as Calypso poses a significant gap in observational data collection, raising concerns about the availability of comprehensive datasets to inform climate science. Participants reiterated the importance of SAGE 3/ISS in filling this void over the coming years, particularly as the mission continues to generate valuable data on atmospheric constituents like water vapor and ozone. The discussions at the SAGE 3/ISS meeting underscored a larger narrative within the scientific community: the need for sustained observational capabilities amid a rapidly changing climate. As researchers expressed their commitment to leveraging SAGE data for future studies, there was also recognition of the collaborative spirit that drives the mission forward. Looking ahead, the integration of new technologies and methodologies into ongoing research will be crucial in addressing the pressing challenges posed by atmospheric changes. In a related note, NASA astronaut Nichole Ayers recently captured stunning footage of the northern lights from the ISS, adding a vibrant visual element to the ongoing dialogue about Earth's atmospheric phenomena. As she noted, the interplay between beauty and scientific data continues to inspire researchers and the public alike, reminding us of the intricate connections between space exploration and environmental stewardship. As we move forward, the advancements and insights generated by missions like SAGE 3/ISS will be vital in shaping our understanding of Earth's atmosphere and its future. In an awe-inspiring moment that highlights the sheer beauty and unpredictability of space, NASA astronaut Nichole Ayers captured a breathtaking display of the northern lights while aboard the International Space Station ISS on May 23, 2025. Initially focused on documenting severe weather systems over North and South America, Ayers found herself pleasantly surprised when the vibrant auroras danced across the sky, illuminating the Earth's poles. Ayers shared her stunning video on social media platform X, expressing her delight. "The aurora showed up this last weekend when I wasn't expecting it. I was trying to capture the massive storms that went through both North and South America and got a nice surprise. This unexpected enchantment occurred around sunset, particularly visible from regions in the northern United States and Canada where favorable space weather conditions prevailed." During the aurora's appearance, the National Oceanic and Atmospheric Administration (NOAA) issued a geomagnetic storm warning, predicting KP index levels to reach 6 on a scale of 9. Such forecasts indicate heightened auroral activity, making the lights appear brighter and more vibrant. NOAA's Space Weather Prediction Center noted that during this period, interaction between charged solar particles and Earth's magnetic field produced the mesmerizing colors that characterize the aurora borealis. The auroras are the result of charged particles from the Sun colliding with gases in Earth's atmosphere.
primarily oxygen and nitrogen.
These collisions create a kaleidoscope of colors. For instance, oxygen emits green and red light while nitrogen contributes purples and blues. As Ayers noted, we see beauty while scientists see data, emphasizing the dual role of her imagery in both artistic expression and scientific research. Ayers, who launched to the ISS as part of NASA's Crew 10 mission aboard a SpaceX rocket in March 2025, has been sharing captivating views of Earth from her vantage point in space. She has previously highlighted other stunning phenomena, including a time-lapse video featuring auroras captured in late April.
As she continues her 6-month mission, which is set to conclude in July, Ayers remains committed to documenting the Earth's beauty and contributing valuable data for scientific study.
The interplay between space weather and the visible auroras serves as a reminder of the dynamic relationship between the Sun and Earth, a connection that has significant implications for both our planet and the technology we rely on. With advancements in space weather forecasting and increased interest in solar phenomena, this incident not only provides a visual spectacle but also underscores the importance of continuous monitoring and research in understanding our atmosphere's behavior. As the world awaits further insights from Ayers and her fellow astronauts, the recent display of the Northern Lights serves as a poignant reminder of nature's wonders and the ever-expanding frontier of space exploration. Looking ahead, the intersection of scientific discovery and technological innovation promises to unveil even more secrets of our universe. Continuing to inspire future generations of explorers. In a pivotal gathering for atmospheric science, the Stratospheric Aerosol and Gas Experiment SAGE 3/International Space Station ISS Science Team Meeting (STM) convened on October 22 to 23, 2024 at NASA's Langley Research Center.
This hybrid event attracted around 50 scientists, including notable researchers from U.S. universities, NASA and NOAA, as well as international contributors from Canada and Germany.
The meeting served as a platform to discuss the mission's historical context, recent achievements and future directions, emphasizing the critical role of SAGE 3/ISS in atmospheric research. Opening the meeting, Jun Wang, the science team leader from the University of Iowa, and David Flitner, SAGE 3/ISS project scientist, set the stage with welcoming remarks, introducing Richard Ekman, the program's former scientist, who provided an inspiring historical perspective on SAGE missions.
Following this,
Alison McMahon from NASA offered logistical details for the two-day agenda, which included presentations on project updates, future mission synergies, and sessions dedicated to aerosol research and data validation efforts. Flitner highlighted the significant progress of the SAGE 3/ISS mission, which has collected and analyzed data for over 7 years. NASA headquarters approved the continuation of operations through 2026 alongside additional funding aimed at enhancing community validation efforts. 2024 is shaping up to be a year of growth for the SAGE 3/ISS team, Flitner remarked, underscoring the planned activities that include supporting the World Meteorological Organization's International Ozone Assessment and advancing data products for community use. A key focus of the meeting was the unveiling of version 6.0 of the SAGE 3/ISS data products, which were released in April 2025.
Robbie Manion from Langley explained that this update addresses a known low bias in retrieved aerosol extinction measurements,
which will subsequently enhance downstream data products such as particle size distribution and aerosol categorization. The new version is also expected to improve the recovery of atmospheric profiles that were previously compromised by solar activity. The meeting also underscored the importance of collaboration with upcoming missions. Notable was Liat Jagel's presentation of the Stratosphere-Troposphere response using infrared vertically resolved light. Explorer Strive selected for a Phase A concept study within NASA's Earth System Explorers program. Strive aims to provide high-resolution atmospheric profiles vital for understanding climate dynamics, thereby complementing the data gathered by SAGE 3/ISS.
Discussions also delved into the implications of aerosol interactions on climate. Mahesh Mandakara presented findings related to the global space-based stratospheric aerosol climatology GLOW-SSAC, which is essential for modeling the climatic effects of stratospheric aerosols.
Zhang Jianlong shared plans for a new project focused on enhancing stratospheric aerosol analyses. While Sarah Liu's research on smoke aerosol radiative effects emphasized the need for ongoing studies in this area. Day 2 featured presentations emphasizing advanced modeling techniques and the integration of SAGE data into climate models. Stephen Pawson from Goddard Space Flight Center discussed how improvements in modeling the upper troposphere and lower stratosphere dynamics will be crucial for future climate predictions. Similarly, Kostas Tsigaridis from Columbia University highlighted the potential climate impacts of increasing satellite launches, emphasizing the need for more comprehensive emission inventories. As the meeting concluded, a shared sentiment emerged regarding the essential role of SAGE-3/ISS in bridging gaps in atmospheric data, especially considering the anticipated decline in observational capacity with the planned decommissioning of legacy instruments like Calypso and Aura. Jun Wang encapsulated the collective outlook, stating, "The importance of SAGE-3/ISS data cannot be overstated. As we face increasing challenges from emissions and climate variability, our long-term data record is crucial for understanding atmospheric changes." The successful 2024 SAGE-3/ISS meeting fostered collaboration and innovation, showcasing the community's commitment to leveraging atmospheric research for climate science. As future developments unfold, the insights gained from this gathering will undoubtedly guide continued advancements in atmospheric monitoring and modeling, enhancing our understanding of the complex factors influencing Earth's climate. In the ever-evolving realm of space exploration, recent advancements and discoveries have captured the attention of both scientists and the public alike. As humanity continues to delve deeper into the cosmos, the question of what lies beyond our planet remains a tantalizing mystery. From stunning visual representations of distant galaxies to groundbreaking studies on Mars, the latest news in astronomy paints a vibrant picture of our universe. On May 26, 2025, NASA unveiled a breathtaking image of the spiral galaxy NGC 2566 captured by the James Webb Space Telescope JWST. This galaxy, located approximately 76 million light-years from Earth, exhibits a bright center likely housing a supermassive black hole, albeit one that is currently inactive. The image, characterized by its 8 diffraction spikes, an optical artifact of the telescope's design, provides a unique glimpse into the turbulent clouds of gas and dust that are essential for star formation. The picturesque galaxy is close enough for earthly telescopes, including Webb and Hubble, to resolve its intricate features, noted the Astronomy Picture of the Day editors. This highlights the ongoing importance of advanced telescopes in unraveling the complexities of our universe. Meanwhile, on the Martian front, new research from Brown University and the University of Bern has shifted the narrative surrounding the enigmatic slopestreaks on Mars. Traditionally interpreted as evidence of liquid water flows indicating potentially habitable environments, this new study suggests that these dark features may instead result from dry processes associated with wind and dust activity. Dr. Adumas Valentinas, a postdoctoral researcher involved in the study, emphasized, "Our study reviewed these features but found no evidence of water," underscoring the ongoing debate about Mars' current environmental conditions. By employing machine learning techniques, researchers created a comprehensive map of over 500,000 slopestreaks, revealing that these formations are more likely linked to factors such as wind speed and dust deposition rather than moisture. This revelation has significant implications for future Mars exploration and the potential for microbial contamination from Earthbound missions. As discussions around Mars gain traction, the vision of establishing human colonies on the planet by 2035, as depicted in Andy Weir's novel The Martian, remains an intriguing prospect. Weir's narrative suggests that by this time NASA will have successfully landed humans on Mars multiple times and developed efficient return-to-Earth flight systems. However, the reality is more complex. Despite the potential for crewed missions, NASA's focus has shifted towards lunar exploration through the Artemis program, leaving the timeline for human settlement on Mars uncertain. Ari Koppel, a planetary geologist and contributor to NASA missions, highlights the critical role of robotic missions in advancing our understanding of Mars.
Robotic discoveries have reshaped scientists' understanding of the planet's surface and its evolving climate, he noted, indicating that while human exploration is a goal, robotic missions continue to yield invaluable insights. In this context, the Mars Sample Return mission becomes paramount. This ambitious project aims to bring unaltered samples from Mars back to Earth, enabling scientists to perform detailed analyses with advanced instruments. As Coppell points out, the sample return campaign stands to provide far more insights into habitability and geological history than sending humans to the surface at this stage. This underscores the importance of maintaining a robust budget for robotic missions, especially as proposed cuts threaten NASA's planetary science initiatives. While the dream of colonizing Mars captivates the imagination, the challenges involved in establishing a human presence on the planet are daunting. The allure of exploring Mars, as popularized by films and literature, must be balanced with the realities of planetary science and the need for rigorous research. As we continue to explore the cosmos, the interplay between robotic missions and potential human exploration will shape the future of space travel and our understanding of life beyond Earth. As we stand on the cusp of new discoveries, the advancements made today will not only expand our knowledge of the universe but also ignite the human spirit of exploration. With each image captured and each study published, we move closer to answering fundamental questions about our place in the cosmos and the possibilities that await us on distant worlds. The journey is far from over, and with ongoing research, the next chapter in humanity's exploration of space is just beginning. In a captivating blend of cosmic discovery and geopolitical maneuvering, the world of space exploration is witnessing significant developments that could redefine humanity's presence beyond Earth. As nations prepare for a new era of lunar exploration, two recent stories are making headlines: the unveiling of extraordinary lunar discoveries and the establishment of a lunar time standard by the United States. On May 26, 2025, NASA's Astronomy Picture of the Day featured a stunning infrared image of the spiral Galaxy NGC 2566 captured by the James Webb Space Telescope. This captivating image serves as a reminder of the vastness and complexity of our universe. NGC 2566, located 76 million light-years away, is notable for its bright central bar and prominent outer spiral arms, suggesting the presence of a supermassive black hole at its core. The image not only showcases the beauty of cosmic structures but also highlights the telescope's abilities to resolve turbulent clouds of gas and dust where stars are born. As astronomers continue to explore these stellar phenomena, they unlock secrets that may shed light on the origins and evolution of galaxies. In contrast to these distant cosmic wonders, the geopolitical dynamics surrounding lunar exploration are becoming increasingly complex. The U.S. has recently announced the creation of Lunar Coordinated Time (LTC), a new time standard designed to facilitate operations on the Moon. This initiative represents a crucial step in the United States' strategy to lead the next phase of space exploration and establish a sustained human presence on the lunar surface. Historically, lunar missions have operated on Earth-based time, specifically Coordinated Universal Time (UTC). However, due to the Moon's weaker gravity, time runs slightly faster there, by approximately 59 microseconds per day. This seemingly minor discrepancy can translate into significant errors during complex operations such as landings and robotic maneuvers. The introduction of LTC aims to mitigate these timing issues by deploying high-precision atomic clocks on the lunar surface by 2026. This synchronization will enhance navigation accuracy and streamline communications between Earth and lunar missions, ultimately paving the way for more ambitious undertakings. The establishment of LTC also holds broader implications for international collaboration in space. With multiple countries including China, Japan, and members of the European Space Agency planning their lunar missions, a standardized time system will facilitate interoperability and reduce the risk of miscommunication. As Brian Foster of Glass Almanac notes, this initiative positions the U.S. as a leader in defining operational guidelines for lunar activities, which carries significant geopolitical weight. Meanwhile,
Scientists are also delving into the mysteries of lunar geology, particularly regarding the unexpected magnetic properties of certain lunar rocks. Research led by Isaac Narrett at MIT suggests that an asteroid impact billions of years ago may have temporarily amplified the Moon's magnetic field, magnetizing rocks primarily on the far side. With upcoming missions targeting this largely unexplored region, researchers hope to uncover more evidence that could corroborate this theory. As Narrett explained, there are large parts of lunar magnetism that are still unexplained, indicating that future explorations could unveil even more surprises. As these developments unfold, they signal a pivotal moment in humanity's quest to explore and utilize space. The intersection of scientific discovery and strategic positioning illustrates how the Moon is not just a destination for exploration but also a stage for international collaboration and competition. The coming years will likely bring further advancements in lunar science and technology, as well as a clearer understanding of how nations can work together or compete in this new frontier.